I will show you how to make this effect. It's a particle follow the curves. This effect, I think I always use this effect in Cinema 4D. There is a plugin called X Particle, and if you use Houdini, you can make this very easily too. So, but in Blender, it's not that easy. But now we have geometry node, so we can make this, and it's quite easy. So let's begin our tutorial. So here we go to Blender4.1 and we go to geometry node here. So I need this section bigger. So press new, and we will need. I will explain the main principle that I will use the simulation zone and a sphere. I will distribute the points on the sphere, and I need a set position here, and I will use a curve. I use a spiral for test. You can use other curves, like you can customize some curves. It's all okay. We will need the tangent value of this spiral curve. So tangent, yes, curve tangent. So this is the main structure. So let's go to details. Of course, we will need to distribute points on faces, and next I will define the force, I mean the vector, that can connect to offset and make the points move. Here we will we want to make the points move along the spiral curve. So I prefer I use stone node attribute here. It's a vector, and it's spline, and here we will name it tangent. And then we will convert the curve to mesh. Yes. So we will why we need this step, because we will use the point here. We want to know which point in the spiral is close to the point, and the point here will sample the closest point on the spiral to get the tangent value, and then we can use the tangent value to drive the offset. So we need a sample. We will sample nearest, and the point, index. Sample index and vector, and the value is mesh is here. Value is named attribute. Tangent. Then we connect here. So let's check what happened. And I will use that join geometry. To check the spiral. Okay, the spiral is weird. Okay, we need more resolution. Like this, yes. And it's not following the spiral. Okay, I made a mistake that stone node attribute to sample the curve tangent here. We will need to use the point, not the spline. So when we press play, and it will move along the curve, but look, it's move everywhere. It's spreading outside, move like this, and we want to control it. So here, first here, I will name it. This is the force, yes, force along curve, and we need to define a limitation that can limit the force only around the curve. So here we will need a proximity here, and we need a distance value. We will need a map range. We will need a 0 to 1, change it to 1 to 0. And we will need a mass vector. Here, we will change it to scale. And we will use this value to control the scale. Here, the proximity is that when it's close to the curve, it will be 0, and it's far away, it will be like infinite big. So here I choose 0 to 1, change it to 1 to 0, and if it's close to the curve, it will be 1. It means I want the force to be big when it's close to the curve, and when it gets far away, the force will go down to 0. So here, let's check again. So I will make the force smaller. Yeah, like this. And I think, let's check. I think the bone is too big, so I will make it smaller, like this one. No, too small. Yeah, and I will transform the spiral. Transform the geometry, make it close to the source. Here, like this. And then let's check. Yeah, we succeed. And don't forget to save the test. And we want more particles, of course. So we need a join geometry. Here. And let's check again. Yeah. And we want the point born randomly. So we need a frame. Let's check. Yes, like this. So simulation nodes. Here, yeah. Here, make it clear. And when we press run, and you can see that the point will go out infinitely. We'll go to 500. So we will define the time. It's the original value is 0, and the time point integer, yes. And we will name the attribute here. change it to integer, and we will need the time, and we will need a math to add the time every frame. Yeah, connect here at 1. So then we successfully defined the time, and we will delete geometry when the time is kind of bigger than a value. So we need to compare. If it's greater than a value like maybe 200. Let's see. Sorry, I just connected to the wrong socket. That I made a mistake. Sometimes I made a mistake. Yeah, you can see that. And you see the time. I need to make that clear. Delete as per time. And next, we want to make the particle more randomly, because you see that it's not kindly very predictable. So we will add a noise. So you may know that we will add the noise here. We need a mass add, and we will need a noise. Yeah, it's going up. And let's map range from 0, 1 to -1 to 1. And we need a scale, of course, to here. See, it will be kind of random. Let's start from 0. And I will change it to 4D. And I will add a frame to make the noise move, so we can have a more randomly effect like this. Yeah, you can tweak the value of the noise. So you can also add extra forces like this, like the noise. I will name it noise force. So when you make the spiral bigger, like rotation 2, 1, 2, 4. We need to delete the viewer. Yeah, see that? And I need to make it higher, like height higher, to make the source smaller. And make the density bigger. Yeah. And this is the final step, that we set point radius. You see this symbol, that it means there's some error in this step, because it can change the radius of the points, but can't change the value of the curve, because the curve is linked to here. So it doesn't matter, it won't affect the curve, so I will use a random value. change it to like this, maybe smaller. Smaller is perfect. And we will set material. We go to cycle here and go to shading, go to cycle and emission. Yeah, see that? And I think the points is still a little big, and I want smaller, and I will need more points. So if your computer is good, you can add more points, it will be better. And to make this stable, I will need a bake. And choose to animation and bake the animation. And check this whole node. It's very short and it's very easy. So now let's test if it works with other curves. So mesh circle. Let's put it here. Yeah, see that? It's rotating, and it's rotating very fast. So I think this the points is a little big. I need a smaller point. Yeah. And I think I need an attribute to define the color. I will change it to color, and I will name it color. So I will use the force here, vector force. So when we go to shading and attribute, color, yeah, like this. And then we can use a ramp. Okay, if we choose the vector, we can choose the color. And why is this color? Because the range of the vector, we can need a, we need a, no, not this one, a map range here. Because the range of the color is okay. Go to geometry node here. I will show you. And name the attribute. Color here. We will check this this form, that color here. Okay, I will define it as a float. That will be easy. Check this value is very small. So change it to float. Now this is okay. Delete this and go to shading. Now I think the value is like 0.5. Is okay. Yeah. See this. And add more color. Just tweak the color. You can get what you want. So go to geometry node. It seems that it can work with other curves, and we can join geometry here and put them together. Let's see what will happen. Okay, go to here. It will be like this. Go to shading. You can tweak the value of the force and the color. And I think that's all of this tutorial. It's very easy. And thanks for watching. Bye bye.